and then we will go ahead and have Advaita present your project.
Okay, just sharing my screen. Is my screen visible and I'm audible?
Yep, can see and hear you.
Okay. So for this cohort, I decided from the beginning only, I was very much interested in the Verkle Tree implementation, and finally I decided to contribute for the to the Nimbus client by providing a Verkle Tree implementation in name. So if we why Verkle Tree, what is what's the use of it, and why do we care? So current implementations of in the Ethereum ecosystem is of Merkle tree or modified Merkle Patricia tree. It's a very good DS, but the proof size is sometimes for hexadecimal Merkle tree is 47 MB. Now it's sometimes very difficult to send over the 12-second slot and efficient to achieve statelessness. So on 2018, a paper stated of Verkle trees from MIT, and it suggests working with Peterson commitments and elliptic groups to provide a constant proof size. This was initially not constant proof size; it was log of n, and later with some mathematical construct, it was changed constant size. For that, you can refer Tankred's blog post. So this is the reason why we want to transition to Verkle tree, and how Verkle came into existence is it's a fun fact that I found that there's a German word. I don't know exactly how it's pronounced, but it also means to shrink and reduce. So it kind of resembles uh, how Verkle tree is shrinking the proof size. And also there's another the major accepted thing that is vector commitment plus Merkle. So here comes the vector commitment. So Verkle tree, instead of collision resistance hash functions, they use vector commitments. So what is actually a commitment? We'll get to that later. An overall view of how a Verkle tree looks like, how the data is there, how the suffix tree there, and here we use Peterson commitment to generate the commitments. But this gives a very complicated view, and if someone is not already into this ecosystem, it's very difficult to get an understanding from the initial look. So we can take a look at the rather simpler view. So this is from the original paper, which was from the MIT. So what a Verkle tree does is, suppose there are nine data from F0 to F8, and from we first decide the branching factors. For this example, it's three, and we divide the data, and then we generate the commitments. And along with the commitments, we also give membership proofs, which is the pi, and we keep on doing this level by level until we generate the root commitment. And it seems very similar to the Merkle tree, and actually it is, just instead of hashing we are generating these commitments like from an overall view. So what are these commitments, and uh, why does it matter, or why are we shifting to this commit? In simple, a commitment gives a proof, and the evaluation is very computationally cheap. So once the proof is generated, for example, if we take example of a prover and a verifier, the prover can commit to a polynomial, and later the verifier can ask to prove compute the polynomial at point u and send a proof, and he can just verify using the proof and the computed output if the computation was right or not. And this verification is actually very good, computationally less costly, and so this gives us the advantage of like less proof size, and also we can verify the proof pretty fast. So what is the current scenario of the Verkle tree implementation? So you can get more details and updated data on Verkle.info. You can see that Geth and Nethermind is already implemented, and that they are joined the testnet. But a lot of migration stuff is left in the EL clients, and also implementation in Besu. And Nimbus also have like their EL client on process, like it's not ready yet. Is also pending for CL clients too. What I'm going to contribute, I'm going to create the Nim library like the Verkle Tree library in Nim for the Nimbus client, which they can use to migrate. And also in this process, I would be contributing to the Constantine implementation, which is a primitive crypto library in Nim, because we would be needing it for the Verkle Tree implementation. But a few features are not there, which we need to contribute. So what are the Verkle tree specs that we are going ahead with? It's pretty standard. So Banderwagon, we will be for the curve, for the elliptic curve, we will use Banderwagon. It's just a scheme built on top of Bandersnatch, and it solves the cofactor issue for twisted Edward curves. And for the commitment schemes, we would be using IPA multipoint, which helps us generating a single proof for multiple points. And obviously, for the Verkle tree, it would be a try. So what would be the roadmap that we'll be going ahead with? We had a meeting with the Nimbus team and finalized an initial roadmap after one meeting, that first we will be preparing the crypto libraries because a lot of things are not there. Like Bandersnatch is implemented, but we need to go ahead and implement the Banderwagon to Constantine, and also include some serialization functions. So that things needs to be done. Also, we need to add the IP and bidder set to the Constantine implementation, which we will be needing in later stages. And once that is done, we can uh, kind of start with the implementing the IP multipoint, which would be a very Verkle tree specific. So that would be getting contributed to the NIM library only. And once that is done, we have a plan of benchmarking with the Go IPA implementation. It's not finalized yet, but maybe we have some benchmarking. And after that, we can start building the Verkle tree library, like implementing the interface and what are the interface that we can see in the Rust and Go IPA. We can cross-reference that, and also we will be having some benchmarking after the implementation is complete. And the migration part is very dependent on time. If we have time, uh, and then we will start with the migration process, thinking about it a bit. But this part is very skeptical. It is very dependent on how much time will these previous roadmaps take. So what are the possible challenges that we can come? First is estimating the time, because while contributing to the Constantine, we have realized that a lot of like things are not there, and it's not when we are starting to implement, we are seeing that okay, this is remaining, and then we have to again go back and implement them. So until unless we are getting and sitting and coding, it's very difficult to estimate a timeline. So this is gonna be a challenge. That's why I haven't kept any timeline like week 2 to week 3 we will do this or that. Uh, and also another challenge is the limited resources, because the faculty resources are very much scattered. Do like in some of the places like Verkle.dev, it is getting compiled slowly, but with collaboration support, we kind of tackling this. And another major challenge would be in this time we have to also keep performance optimizations along with code readability. I'm not sure how we are going to achieve this like in the short time, but obviously that would be a, like that's great. And there's something extra that came up in the last 2 to 3 days. I decided to like to sum up the development specs of a Verkle tree, and then Mario suggested Verkle.dev, and I then checked that Verkle.dev, and it's amazing. It's getting built, but it lacks here and there things, and a lot of things are on process, and it's not the peers and not much. Also dev contributions, like dev specifications are also remaining. So instead of writing a document separately, I will be contributing to this Verkle.dev, stating the specs. uh, like this is some kind of extra, this came up later. So I hope this would be a very good contribution, because having everything regarding Verkle tree in one place is like it would be a very huge time saver for anyone in future who wants to develop implement Verkle trees. So that's all about my presentation. And if you have any questions, do shoot me.
Awesome. Thanks so much. Great presentation. Glad to hear that you'll be contributing to the Verkle.dev documents. That sounds like a very worthy contribution. Any questions or comments? All right. Thanks once again, Advaita.
Thank you, everyone.
Next